There was a time in American heavy industry when the name painted on the side of a mining truck did not matter, as long as that name was Euclid. They did not just build off highway haulers, they invented the entire concept. Before them, moving earth meant laying temporary railroad tracks or relying on fragile, modified highway trucks that shattered under the strain of the pit. Euclid built the first true heavy-duty dump trucks, painting them in an unmistakable, iconic shade known as pioneer green. For decades, they owned the earth. But by the late 1970s, the undisputed king of the dirt was fighting a desperate, losing battle for its own survival. The Mesabi Iron Range, Minnesota, 1978. The ambient temperature on the floor of the pit is 20 degrees below zero, and the wind chill dropping off the high wall makes it feel like minus 40. Everything in this environment wants to break. Steel becomes dangerously brittle. Hydraulic oil thickens into useless sludge, and the red taconite dust, a violently abrasive byproduct of iron mining, is frozen completely solid into jagged, unyielding ruts across the haul road. Grinding up a steep 8% grade out of the deep pit is a towering machine painted in that legendary pioneer green. It is heavily weathered, caked in frozen red mud, and blowing a massive column of thick black smoke into the freezing Minnesota sky. This is the Euclid R-170. It is hauling 170 tons of brutal, raw iron ore. It is massive, it is deafeningly loud, and it is a mechanical ghost walking toward its own corporate execution. To understand the R-170, you have to understand the sheer, stubborn pride of the engineers who built it, and the absolute panic that forced their hands. For generations, Euclid completely dominated the Earth with traditional, bulletproof mechanical drivetrains. But, as payload demands violently pushed past the 100-ton barrier in the 1960s and 70s, competitors like Unit Rig and Wabco proved beyond a shadow of a doubt that diesel-electric drives were the only mathematical way to survive the relentless physics of the high wall. Mechanical transmissions were snapping. The industry was evolving rapidly. Euclid, the proud grandfather of the haul truck, was forced to adapt or die. The R-170 was their colossal, diesel-electric answer to an industry that was rapidly leaving them behind in the dust. Beneath the heavy steel hood of the R-170 sat an absolute monster of American combustion. Buyers had options, but the most legendary configuration utilized a roaring, 16-cylinder Detroit diesel two-stroke engine. This block produced an incredible 1,600 horsepower. But unlike a modern, quiet four-stroke diesel, a two-stroke Detroit did not rumble. It screamed. Because every downstroke was a power stroke, the engine fired twice as often, relying on a massive root-style blower to violently force air into the heavy cylinders. The acoustic violence of this engine, running at maximum RPM under a heavy load, was completely deafening. It possessed a high-pitched, mechanical fury that shook the heavy steel deck plate and rattled the teeth of the operator sitting in the cab. But that massive Detroit diesel was not connected to a transmission. There was no drive shaft. The roaring engine was merely a prime mover, turning a massive General Electric alternator, sending raw, lethal direct current to GE traction motors mounted deep inside the rear wheel hubs. The veteran operators who sat in the high, offset cab of the R-170 experienced a machine of violent, psychological contrasts. The engine screamed with an analog fury that suggested the truck was tearing itself apart, yet the acceleration of the electric wheels was perfectly smooth, eerie, and relentless. There was no clashing of heavy gears, no sudden drop in momentum as a transmission struggled to find the right ratio on the steep Minnesota ramps. But operating an electric drive Euclid in the bitter, sub-zero cold of the Iron Range introduced a terrifying physical variable. Taconite iron ore is incredibly dense and aggressively heavy. When 170 tons of it were dropped into the heavy steel box by a massive electric mining shovel, the weight settled with a brutal, unforgiving shock. In freezing temperatures, the massive high-tensile steel frame of the truck became incredibly brittle. To protect the frame, Euclid utilized a highly unique suspension system known as neocon struts. Instead of traditional steel springs or pure nitrogen over oil cylinders, the neocon system relied on highly compressible silicone fluid and engineered rubber blocks to absorb the massive kinetic impact of the loading face. But at -20 degrees, the rubber and silicone fought back. The suspension became agonizingly stiff. When the shovel runner released the payload, the violent shockwave bypassed the frozen suspension and transferred directly into the chassis and straight up into the spine of the operator. Once the truck was loaded, the battle truly began. The veteran operator had to constantly, obsessively read the frozen haul road. The massive dual rear tires, each standing over 10 feet tall, had to grip the frozen, heavily rutted taconite. The R-170 possessed absolutely no modern digital traction control. It relied entirely on the sensory integration of the human being holding the steering wheel. If the rear tires hit a patch of solid blue ice hidden under the red dust, one of the massive electric wheel motors would instantly lose physical resistance. The sudden lack of load would cause the electric motor to overspeed violently, creating a massive, highly dangerous electrical spike in the control cabinet. The operator felt this instantly. The deafening scream of the Detroit engine wouldn't change, but the physical vibration of the truck would suddenly shift as the massive tires lost their bite. In a fraction of a second, the veteran had to feather the throttle, starving the alternator of RPMs to drop the voltage, artificially bringing the spinning wheel back into perfect synchronization with the frozen earth. If they failed to catch it, the massive electrical surge could easily fry the heavy contactors in the control cabinet, leaving the 170-ton machine completely dead, blocking the entire haul road in the middle of a blizzard. The physical exhaustion of driving the R-170 was absolute. The steering required constant, heavy correction. The operator was completely isolated in the cab, fighting the brutal chill that seeped through the heavy door seals, surrounded by the smell of burning diesel, hot electrical ozone from the control cabinets, and the metallic tang of iron dust. When it was finally time to bring the massive, fully loaded machine back down a steep ramp to a lower bench, the operator relied entirely on dynamic retarding. By altering the electrical circuit, the massive traction motors in the rear hubs stopped acting as motors and instantly became massive generators. The sheer physical resistance of generating that electricity acted as an invisible brake, holding back hundreds of thousands of pounds of rolling iron without a single piece of mechanical friction. But this process converted the truck's terrifying kinetic energy into immense amounts of electrical heat. This deadly heat was routed straight into a massive bank of heavy metal resistor grids mounted directly behind the cab. On a sub-zero night shift in the Iron Range, the sheer thermal energy radiating from those heavy grids was a spectacle of physics. The metal coils would glow a dull, lethal orange in the darkness. The intense heat would violently collide with the -20-degree ambient air, creating massive, swirling heat distortions. Looking in the rearview mirrors, the operator saw the world violently warping and melting behind them. The R-170 looked like a machine, descending into a mirage of its own making. If the cooling blowers for the resistor grids failed, or if the operator took the grade too fast and oversaturated the electrical limits of the system, the grids would physically melt, raining molten metal down onto the deck plate and leaving the massive truck in a terrifying freewheel. The operator drove with one eye constantly fixed on the grid temperature gauges, completely managing the survival of the machine through strict sensory discipline. The R-170 was a masterpiece of heavy, stubborn endurance. It proved beyond a doubt that Euclid could engineer a world-class electric truck capable of standing toe-to-toe with unit rig and Caterpillar. It moved millions of tons of heavy earth across the globe. But the incredible survival of the machine on the dirt could not save the brand in the sterile environment of the corporate boardroom. The death of Euclid was not caused by a snapped frame, a blown electric wheel, or a failed engine. It was caused by federal lawyers and corporate spreadsheets. Decades earlier, the United States Department of Justice, terrified by General Motors' absolute, undeniable monopoly over the heavy equipment and off-highway market, filed a massive antitrust lawsuit. They forcefully mandated that GM had to sell off the Euclid brand. What followed was a tragic, agonizing, decades-long corporate dismemberment of an American icon. The legendary brand, the very company that invented the heavy haul truck, was bounced around like a toxic asset. It was sold to the White Motor Corporation. When White Motor faced financial ruin, the Euclid name was passed to Daimler-Benz. From there, it was shuffled to Clark Equipment, then absorbed into a massive, soulless joint venture known as VME, and finally, completely swallowed whole by Hitachi. With every corporate acquisition, a piece of the original proud Euclid identity was violently stripped away. The engineers who had spent their entire lives perfecting the heavy iron either retired or were replaced by corporate efficiency experts who had never stepped foot in an active mine pit. As the 1980s closed and the 1990s began, the final, fatal blow was struck. The iconic Pioneer Green, paint the color that had proudly defined American earthmoving for over half a century, was quietly and unceremoniously discontinued. The heavy Euclid nameplates were unbolted from the massive steel grills and thrown into the scrap bins. They were replaced by the bright yellow paint and modern corporate logos of the conglomerates that had bought their legacy. Down in the brutal pits of the Mesabi Iron Range, the remaining Euclid R-170 fleets were slowly, agonizingly run into the ground. Their massive Detroit engines were pushed to the absolute limit of their mechanical lives. When a truck finally suffered a catastrophic electrical failure that the mine accountants deemed too expensive to fix, it was dragged to the deadline. There, it became a cannibalized donor. Mechanics aggressively stripped the heavy contactors, the grid blowers, and the General Electric wheel motors just to keep the dying remainder of the green fleet alive for a few more brutal months in the freezing mud. The exact knowledge of how to operate them, how to perfectly feather the throttle on solid ice, how to brace for the brutal shock of the neocon suspension at 30 below zero, how to read the glowing orange heat of the retarding grids went with the old-school operators when they packed up their lockers and retired. None of it was ever documented in a corporate manual. If you respect the iron and the blue-collar history of these mechanical legends, hit that like button and leave a comment down below. If you ever turned heavy wrenches on a Pioneer Green Euclid, or drove an R-170 through a freezing night shift in the Iron Range, what was the specific? Mechanical sound, the dynamic retarding grids made right before they reached their thermal limit? The name Euclid built the heavy industrial foundations of the modern world. But today, the name is completely gone, legally erased from the deep pits and steep ramps they once entirely dominated. The iron remains, rusting silently in the forgotten corners of the dirt, the last true ghost of the original American earth-moving empire.